Hello, everybody. We're going to talk today about object relational mapping and my understanding of it and why I believe that object relational mapping is actually an anti-pattern instead of a pattern which we all have to use. It's very popular. It's used everywhere. It's used in Java world in many projects. I think in almost every project which is anyhow is connecting to the database, relational database, the ORM is used there somehow. The most popular one is Hibernate, and there are many others. And in Java, it's even the standard now, which is called Java JPA. And I think that this is a quite wrong approach if we are talking about pure object-oriented approach, and we want to work with objects instead of data and procedures. So the question is that, first of all, just a few words about what it is. So it is the mapping. There are three words: object relational mapping. The mapping means that we have some relational database, the database with tables and rows and cells, and we have on one side, and on the other side we have a Java world and Java objects, and we want to manipulate. With relational data in the world of objects, of Java objects. And that's why we need some kind of mapping. So we want to work with Java objects. At the same time, all the manipulations we do with the objects should be somehow translated to actual SQL transactions in the end. And in the end, we want to manipulate with the data in the relations, in the tables. So the mapping is important. So I'm not saying that the entire mapping is a wrong idea. It's a good idea. So we do need to map relational data to object world somehow. But the way it's done in Hibernate, for example, is wrong. That's what I'm trying to say. So I'm not against the mapping in general. It's an important mechanism because we want to manipulate with objects and not the data, not the cells and columns. But the way the mapping works in JPA or Hibernate, in a classic ORM, which are in other languages as well. For example, in Ruby, we have active record, or in PHP, we have doctrine, for example. All of these frameworks, they're actually kind of copies, or they got their ideas from Hibernate, from Java in some way. So I'm against that. I want to show you the diagram which I made to illustrate illustrate what I'm saying. And here is let me share it with you. 1 second. Here it is. So this is how, for example, Hibernate or classic ORM works. So on the left side, you see a user, or it's a piece of code. This symbol is a piece of code. So I'm a client, and I want to basically rename a record. I want to change the name of a user in a database. So I have some database, and I have in that database I have a table. The table name is user, and inside this table I have a record, and I want to rename this user. So I'm saying user.rename, and I give a new name for the user. Jeff is the new name. So in a classic ORM, it goes into the method which is called rename, and then inside the object of class user, I just change the internal variable name, internal property name, and I set the Jeff in here. And then this is my first step. And then the second step, I go to the session of the ORM. For example, in Hibernate, I go to the session and I say update, and I give my object an instance of class user. I give it as a parameter, and then I call the method which is called update. And this another object, which is a session, actually creates a statement for the JDBC, and then JDBC connects to MySQL and sends update user set name to Jeff, where ID is 123. I'm sure you understand how it technically works. So there are basically two steps. The first one, let me reiterate it again. So the first step, I have an object. Well, it looks like an object. It is an object. So I have this thing an instance of class user, and I call it, well, traditional, usually it's not actually rename, it's done like that. So I call set name Jeff in the user, and the inside what happens is this name equals to Jeff, and that's it. This is the end of interaction with this object. And then I call session update, and I give it to user, and inside the update method, somewhere here, I believe something like that will happen. So the Hibernate, the ORM, will get the name which I just set here. So I set the name into this collection of data, and then I pass this collection of data, so-called object, into the update method. It retrieves the name back. It executes some database statement. It's a JDBC instruction, and then JDBC goes to MySQL. So the JDBC is a library which helps us to interact with the database. This is how it looks in the traditional, in the ORM. So we have 2 entry points. We need to make 2 calls if we want to do something with the object called user. This is what I think is wrong, because it's wrong because the control of what's going on is located here. Because I manipulate with the user. So manipulator of this data, and actually the process of renaming the user is somewhere outside of the user. So that's why I'm calling this ORM pattern offensive, because I do not respect this user anymore. I do not respect this object as a solid self-sufficient, and an object which can do whatever it needs by itself. Instead, I just inject something into the object, and then I let the ORM retrieve something back. So I'm using an object as a temporary holder of data, which I just transfer from some point from myself to the ORM. So it's just a temporary holder of data. That's what it is. That's what this object, so-called object, is. And these 2 arrows here shows us, they show us that in order to do this manipulation of renaming, for example, changing the name of the user, we need to first of all interact with an object, and then we need to interact with ORM engine, which is in this case, which is session, if it's the Hibernate. So I need to talk to 2 different entities. The first one is an object, the second one is a session. That's what makes it completely against the idea of encapsulation in object-oriented programming. And this is how it should be, I believe. Let me go to the next slide. This one. So this is how I think it should be. We should have an object of class user, an instance of class user, and then on the left we still have a client, and the client says rename, not set name, but rename, and then it gives the name, and then this is the method rename, and it goes to, I'm using here the library which is called Juke. It's quite popular, J-O-O-Q. It's quite popular in Java world, and this library just helps me to convert my rename request from an object world, from Java world, to an actual JDBC call, an actual SQL statement. So here I'm saying it doesn't really matter what the syntax is. It just looks more, more Java instead of SQL. So I call update user set name to Jeff, where ID 123 execute, and I go to this library, and this Juke library makes a JDBC request, and the request goes to the MySQL in the form of SQL statement. The client here on the left side doesn't know what's going on. The client doesn't know that the actual SQL, the actual manipulation with the database is even happening. So the client doesn't know whether the object goes to the MySQL or the object goes to file, for example. The client doesn't have any idea of what's going on inside this method name. And there is only one entry point here, which just talks to the object user and to its method rename, and that's it. So there are not 2 lines like we saw before on the previous slide. On the previous one, as you see, there are two lines here. First of all, I need to create an object which is actually not an object at all, just a temporary holder of some data. And then I go to the session and I say, hey, you ORM engine, Hibernate or whatever, do something with my bag of data and just save it to the database, for example. This is I think is a wrong way, and this what I think is the right way. And I will give you now. First of all, I just demonstrated you what the difference is. So this is what I'm suggesting to do. I'm suggesting to encapsulate the entire interaction, all manipulations with the data and database and JDBC, everything should happen inside the object. So the client should not know anything about database and shouldn't be aware that the actual renaming does anything with the database. So the client shouldn't care about that. The client just needs to rename the user. How this rename will happen, through the database, or maybe through the file, or maybe the HTTP request will be sent, the client doesn't care. All the client wants to know is that there's an object, and this is my method name, and I give you the new name, and if you do not throw an exception back, then I'm sure that you actually did the renaming and you changed the name of the user. That's all. In this case, it's not the case. The client must be aware about some session, about some database. The client must know that setting the name Jeff is not enough. That this method, in this case, is going to be set name. That this set name method is not actually changing the name of the user. It's just changing the property inside some data bag. And then I have to go somewhere else and call some update method on some session, and only after that the actual database will be changed. So that's a huge difference. One entry point or two entry points. That's a big difference. And actually, in this case, there could be many entry points, not just one, because in this case, we just set a name and then we update. But if we want to select, for example, retrieve something from the database, it's going to be another entry point. It's going to be, well, it's going to be more, but at least two. I'm not sure about many more, but at least two entry points we need to do for each operation. We need to modify the data bag. I'm calling it a data bag. It's not really an object, it's a data bag. And then I need to pass this data bag somewhere to the session in order to do the actual modifications to the database. So now the question is, so why I think that this approach is better than the previous one? Because the previous one actually works, and thousands of projects in the world, they all use this approach. They use Hibernate, they use these ORMs, and it works. Technically, it works. It's not going to break. It will do what it has to do. It will modify the database. So I'm going to give you 4 reasons. And on the blog, in the article, all of them are mentioned. Not all of them, but 2 of them for sure. I'm going to give you 4 now. Let me stop the sharing and yeah, I can see me. So the first reason of why this approach the traditional approach is wrong is that it doesn't work with an object like an object, but it actually uses, like I just mentioned, it uses this Java object is a data bag. So it's not actually an object-oriented entity, which is called an object, which is supposed to encapsulate everything inside, but instead it's just a structure with data items which we can send somewhere. It's a temporary structure, and we can send it somewhere. And why it's bad? Because the encapsulation doesn't exist anymore. So the object doesn't encapsulate the logic and the data inside. The logic of how this data are being used for actual mapping to the relational database is outside of an object. So the object itself doesn't know how the data which are stored inside the object will be used to create the SQL request. So like in this example, we have the name of the user, which is Jeff, but the object of class user doesn't know how this Jeff will be used to generate the SQL query, because the SQL itself will be generated by Hibernate somewhere else. So first of all, we inject the data into the user, into the object, and then we pass it somewhere. Then somebody else retrieve the data from it and create the SQL request. So how this SQL request will be generated, I don't know. If I'm an object, I don't know. All I know is that inside me somewhere I have this name Jeff, and somebody later will just retrieve it from me. Retrieve it and go away and do something with this data. So there is the core principle of encapsulation is violated, is broken, because I do not encapsulate my logic anymore. I only encapsulate the data. But that's not enough. I have to encapsulate the entire logic of this rename method. So if somebody tells me to rename myself, then I'm supposed to know how this renaming is happening and do all the renaming. So encapsulation with the ORM is completely violated. There is no more encapsulation there. That's why it's the first. It's kind of theoretical, you may call that. It's kind of abstract, but this is the reason of why ORM is a really bad idea. Because if you start using ORM, you will have many of these, maybe hundreds of these so-called objects, but actually data bags in your entire code. You will have them everywhere, and all of them will not encapsulate the logic. So you will have 100 of data bags, quite stupid data bags. All they can do is just store the data, and then you will have some logic somewhere else, which is supposed to manipulate with these data bags. So every time you want to rename an object, to rename, for example, a user, it's not enough for you just to call rename method. You will have to have some kind of a service layer, or I don't know what, but some extra layer on top of your objects. So you will have like a huge amount of stupid, dumb data bags, and then on top of them, you need some kind of a layer of procedures or layer of some scripts which actually know what to do with them. This is what we had in procedural programming. This is not what object-oriented is about. The object-oriented is that we need to get this code and wrap it inside objects, so that objects know what to do and nobody else needs to know what to do with this stuff. But now we turn it completely upside down. This ORM is actually getting us back to procedural programming, away from object-oriented. Now we again have these dumb data structures, like in C, for example, we have this arrays, or in C++ we have these structs, the structures with not maybe a good example, but we have just just data structures, and the code stay away from them. The encapsulation was introduced to solve that problem, and now we're getting back, removing the encapsulation. So see my point? That's why I'm kind of really, it's really sad to see it's happening in Java when it's not object-oriented anymore, just because the encapsulation is violated. That's the first reason. The second one is kind of practical. Again, why it's bad, why the traditional ORM approach is bad, is that you can't test it. I mean, again, because there is no encapsulation, it's really difficult or sometimes impossible to test the logic of this renaming, for example. So we're trying to test. Let's say we have some code which needs to rename a user and then do something else. But we don't want to go to the real database. We want to create some fake user, which will be saying when you're asking it, could you please rename yourself? The object will not go to the database, but will say, okay, it's done. You just did it. Just go on. We cannot do that because the object does not encapsulate the full renaming logic. All the object has is just the data. And if you create a fake instance of this object, it's not enough, because you need to create a fake or a mock instance of some piece of code which is actually doing the manipulation, which is interacting with the database, with the session. So it's not enough just to create, just to mock an object. You need to mock it together with the piece of code which is going to the database. And how many of these pieces of code you have? It's difficult to find all of them. So your code is kind of stuck with the interaction with the database because because your objects are not mockable. They are mockable because they're very stupid and very like simple. You can easily copy, you can easily mock the any Hibernate, this data object they call it. So you can easily mock them, but there's no point in this mocking, because by mocking this data object, you are not actually mocking the real algorithms of manipulation with the database. So you need, again, like I said, you need probably some kind of an extra layer on top of your objects, which will also have some objects, or I don't know what, which will be mockable potentially. So the testing of projects which use ORM is kind of difficult task in most cases, and the best you can do is actually write integration tests and test everything together with the database. Some people say it's not bad, but I'm not saying it's bad, but I'm saying that this is not how object-oriented software is supposed to be tested. We're supposed to be able to create fake instances of all our classes and then put them together and see how one class works. So when you're testing one class, you're creating fake instances of everything else, and then you see how just one class works together with all these fake dependencies. In this case, it's really hard to do that because there is no encapsulation, because the logic of the database manipulations is everywhere, not inside an object. So the reason number 3 why it's bad, that was the second one. Now the number 3 is that it's really difficult, or it's not difficult, it's impossible to decorate our object. So let's say we have an object user, and when the rename is happening, let's say, for example, I want to, let's say I want to show in the log of how long it takes to rename a user. So before going to the database, I want to check what time is it now, and then after it goes back from the database, I want to check again what time is it now, calculate the difference, and say it in the log. The renaming took 1 second. I cannot do that with the traditional ORM approach, because the code which actually does the interaction with the database stays away from my object, and in order to do this calculation, I need to find this place where it's happening, and then I want to somehow to put this time checking into that place, and maybe there are many of these places, and I don't know exactly, well, in how many places I'm supposed to do that. If the method is here, the rename method, and then there are many pieces, many people or many pieces of code which are actually using this rename, and then taking me as an object to the database, to the session. So what am I supposed to decorate? What am I supposed to wrap with this time checking code and logging code in order to make sure that all the renaming, all the calls to the method rename are actually being logged to the console? It's just not possible to there is no point of decorating, of creating the wrapping, the decorators for that user class, because it's kind of dumb, storage of data. It's not a user. In my approach, like I showed you, when there is only one entry point and all the code goes inside the rename method, all the interaction with the database, everything, it happens inside one method, then I can just create another class which will be called user that logs, for example, and then that class will encapsulate an instance of the original class user, and then we'll just rewrite. We'll create a new implementation of the method rename, and in that method it will just, like I said, check the time first, and then call the original rename method, and then it goes back, it check the time again, and log it. And now we're 100% safe. Then everybody who goes to this rename method, all the calls will be logged to the console. It's just one place, one rename method. We decorate this method, we're safe, because we have the encapsulation, because everything is encapsulated inside an object. The Hibernate and all these ORMs, they completely remove that flexibility from us. They turn us into procedural programmers who are supposed to go through the entire code and check every piece where the data are being used and put this extra code in there in order to achieve something. This is the completely step away from object-oriented programming back to procedural programming, back to C. That's what Hibernate is doing. And the reason number 4, also practical one. So the reason number 4, why the ORM is bad is that actually it forces us to use SQL everywhere in the application, where actually there is no SQL related code is actually placed. So like in the diagram I showed you, for the object, to manipulate an object, I need to, if it's just an update, it's not so difficult, because I'm just saying, I'm just calling to Hibernate, update, and I give an instance of an object. But if I want to select something, for example, from the database, then I go to this session, the Hibernate session, and in this session I'm saying, I'm calling select, and then I'm using this specific dialect of, it's not really a SQL dialect, but it looks like a SQL. So I'm saying this select something. It's a language which was introduced by Hibernate. So I'm using this language which looks like SQL in order to select something from relational database. And then when the data comes back to me, these data look like objects, and I start to work with objects. But I have 2 calls again. The first call is a SQL call. Okay, it's not exactly SQL, but it looks like SQL. And the second, it's an object manipulations with Java object. So where is the object relational mapping then? The mapping is supposed to completely hide the SQL from me. I don't want to know about SQL anymore. I want to work with Java methods, and I want to say I want to go, for example, to go to this Hibernate and say, find me all the users who are, I don't know, who are older than 25 years old, 25 years. So I cannot do that using the Java method calls. I need to create some SQL somehow, because I'm still talking. I still need to know this SQL, and it's not a problem for me to know this SQL, but the problem is that where I need to know it, I don't want to know it in this place, because here I'm talking about objects, and I don't want to know that actually there is a SQL database behind these users are there. So I'm on a level where I'm talking about users, files, blog posts, I don't know, images. So I'm on a business level here. I'm trying to put together business objects and business semantic. But the Hibernate enforces me to know about SQL requests. So I need to remember that there is a SQL database somewhere. I need to remember that there is a relational data structure somewhere. And this knowledge about relational structures is going to be spread everywhere across the application. The entire application will know here and there that the entire software stays on top of my SQL database. And this is terrible, because there is no real mapping in this case. The real object relational mapping is about hiding the information about the relational structure completely. So all I know on the object layer is that there are objects who talk to each other through object calls, through methods. And I completely I should completely ignore the knowledge about the relational layer beneath that. So eventually, for example, for testing purposes, or for I don't know, maybe in the future I want to replace the SQL from NoSQL. The business layer should not be affected. In case of Hibernate, it's not possible. If you're stuck with the Hibernate, you're stuck forever with the relational database. Yes, you can change MySQL to Postgres, maybe. But you're completely stuck with relational structure, because your application will know that there's a Hibernate, which means there's relational structure beneath the entire application. In my example, what I suggest, which is called SQL speaking objects, there are objects which encapsulate the knowledge about relational database. And when I call the method rename, then only the object knows that there is a relational database beneath the object. So only my object knows that the MySQL is somewhere, or JDBC is somewhere, or this Juke library is somewhere, but nobody else. Nobody else knows nothing about the relational database. It's just a call to method rename and one argument, which is Jeff, the name of this user. That's it. The entire application will know nothing about relational structure beneath this call. If I want to migrate to NoSQL, I need to modify only one object. I will modify only one class. Maybe it's going to be difficult. Maybe it's going to be impossible. But maybe it will be difficult. Maybe it's not possible to transfer. But it doesn't matter because it's all inside one class. There could be hundreds of classes around of this class user, but none of them will know that I'm working with relational database. In case of Hibernate, everybody will know that relational database is staying under the application and our persistence layer is actually relational. So why it's called Oblique Relational Mapping? There is no mapping actually. It's just a completely incorrect approach to simplifying the work of lazy programmers. Of programmers who are not, who can't spend enough time to create the proper solid object which knows how to manipulate with one or few tables in the database. They just want to do it faster. And we give them the instrument. The Hibernate is an instrument for lazy programmers who don't want to think more, who don't want to spend a little bit more time to design one proper object. They just want some piece of data to persist it in a database and get it back, and they don't really care about the future. So this Hibernate or similar ORMs in other languages is a perfect instrument for bad programmers, for throwaway code, for the software which is not aiming to be maintainable and actually being designed with some good architecture in mind. That's what I think. That's my understanding, and we probably ready for questions. Yeah, we have some questions already. Yeah, we have questions already. So let me select this one. Question number 1, if the object will change the property in line, how to change many properties in the same time without an execute method? I know it's wrong to put an execute method in a user class, for example, but how do you do that? Well, the question is, that's a good question. So let's say the question is more about, say, transactions. So you're saying that if I want to rename a user and then, for example, change the user password. So there are two different methods. The first one is rename. The second one is change the password. In Hibernate, you have the data bag, which is called an object. You set the name, and then you set the password, and then you pass this object to the Hibernate, and Hibernate executes the transaction, which updates two fields in a database at the same time. With my approach, it's not possible because every call to the method is a single call, and it's going to be one transaction. If you really want to optimize that, you want to change them together, you introduce one more method. You introduce a method which is doing together these two operations. You introduce a method which is at the same time change the name and change the password. In this case, it's a completely different transaction. It's a different interaction with the MySQL. It's a different code, the code which optimizes specifically this operation. So you will have basically three methods. The first one, change the name. The second one, change the password, and then the method number 3, if you really care about that. Because in most applications, you will not care about 2 transactions, 2 round trips to the database. That's perfectly fine. But if you really if you care about performance, you introduce the method number 3. So you control how the database is being interacted. So you control how many times you go to the database. Not Hibernate, but your object. It's all in your hands. Not in the hands of the Hibernate, not in the hands of the user who comes to you and the user decides, okay, I'm going to make 2 calls and then I'm going to go to the Hibernate because it's more, because I want to optimize performance. The performance is optimized by just explain the way I explained by objects of this class. I hope I answered the question. Let me try another one. How do you think about applying repository pattern? Never call model directly, but always via repository. Repository pattern. Well, I'm not exactly sure what repository pattern is about here, but I think you're talking about some say, you're probably talking about something which represents the table or even the database, and then I go to this big object and I say, change the name of the user, and here's the user ID, and here's the user new name. And this repository or a table or a database just does all the interaction with the specific table and specific row and specific cells and changes everything. Instead of, first of all, having the user and then in the user calling rename. So this, I think this is what repository pattern is about. I think it's not bad. Anything is good as long as you encapsulate database interactions inside your object. So actually, this is probably a good approach if you just start working with the application. You start a new software, you're building a new system. You don't want to create many objects which actually model the entire database. For example, you have a database with like 15 tables. And then you want to create an application which is going to be able to change something in a few tables. You don't want to create 15 different objects and implement all the 15 different classes in Java. That's a lot of work. You just create one object and you call it database. And in this object and database, you introduce a method which is called rename a user, or store a blog post, or show me all the blog posts. It's perfectly fine, as long as you encapsulate everything inside this object. When the application grows, when the application becomes bigger, then you break this object down into pieces and you say, okay, this is not enough anymore. I need an object which is called users. And then I need an object which is called user. And you still don't need objects which are called posts or blog posts or images or something else, because you don't have this functionality yet. But you extract two objects, posts and blog posts, and you implement the database interaction inside these objects. So repository pattern, if I understood you right, is perfectly fine as long as you work with, as long as you encapsulate the database interaction inside your objects. The next question. How do you handle relationships and complex queries? Joining between different databases without ORM. I know ORM is very efficient. It's never efficient. Yeah, that's a good question. I had it. Many people asked it on the blog. So yes, on the modern ORM, on the Hibernate, for example, it's really convenient to join together. Well, sometimes it's convenient, sometimes it's not really convenient. To join together a few objects, a few tables, a few complex queries, and build these complex queries. I think in general, it's really terrible that the ORM is actually allowing programmers to work with relational data without understanding how to build queries, how to build SQL. This is what actually Hibernate is doing. So in most cases, people and programmers and me and myself as well, we just forget SQL. We forget how to build a proper query, a proper request in the SQL, because Hibernate is doing it for us. And in the end, we have the code, we have our objects which are operating with and our, not just objects, but the entire application is becoming inefficient in operating with the database. Mostly because the Hibernate hides the details, doesn't show us the details of how these complex requests are being created. And then we start to optimize, and then we start to fix the performance issues, and then we start to dig deeper, and we can't find how the Hibernate is actually building this request. And that's a nightmare, because it's completely hidden from us. We don't see how it's happening, because all we have is just this annotations. We just annotate these methods inside our object. We somehow create maybe sometimes XML configuration of how these objects are supposed to be connected to each other. It's a completely new language for us. It's a completely new knowledge for programmers. They need, instead of learning SQL, which is a relational algebra-based language, and it's a language with some logic. It's a language with some scientific background, scientific reasoning behind this language. we completely get away from that, and when we get to and we go to this Hibernate language and a Hibernate logic and some XML configuration files, and we need to understand how to write this XML configuration files in the right way so that the Hibernate will understand us and create the most effective requests, the most effective SQL request to MySQL. This is terrible. This is just against the principles of maintainability and against the principles of encapsulation and the principles of transparency. We just don't see how our code gets into the MySQL. What's the clear path of that? So my answer here is that all the SQL requests must be built by some libraries like this Juke library, for example, which helps you to build SQL requests. Or I have my own library for that, which is way simpler, but still, you need to see how the SQL request is built. When your object is supposed to do some complex manipulations with the database, so the path from calling a method to executing a SQL query must be clearly seen by one programmer in one file. So you should just be able to open a file and see how this request is being created. One file, one method, just that size on your screen. So you should see that, okay, this is the request, these are the parameters, this is how they're being translated into SQL request. And that's where my code is, for example, too slow. Or this is where I lose the data, or this is where it gets stuck. It should be in one place and one method. The ORM completely tears apart your project into pieces, and it's really difficult to find out how these complex queries are being built. So no ORM. Everything in methods, and everything should be clear from start till stop, from the Java call to SQL request. That's what I believe. Next question. How this design is related with domain-driven design, and more specifically, the repository pattern. So probably I don't understand, because I tried to answer about the repository pattern, and probably I just didn't understand what the repository pattern is, because you're saying that domain-driven design and repository pattern, this is something I cannot, well, I'm not an expert in this domain-driven design, so I can't answer this question, but I can try. I'll try, and maybe I'll be wrong, but as I said, I'm not an expert. So I think that I think that the Java code should look, the Java developer, when working on the code, should speak the same language as the business analyst or the customer is speaking. So the properly designed Java code has objects which have same names and the same semantic and the same methods, the same interaction patterns as the real objects in real life. So if in real life we have a car and a garage, then in the Java code, in a properly designed Java code, we should have the car as a class name and the garage as a class name, and they should interact in a similar way as they interact in the real business world. So when I design the code by looking at the real world, I, as a designer, as an architect, I should try to name the classes this way, and then I should try to make sure they interact the way they interact in the real world. But this is only about the Java world I'm talking, only about object part of ORM. But when you go deeper and you start to create relations, to create tables in the database, then this statement is not true anymore, because it may be true. You may have the car relation, but you're not going to have the garage relation, for example. So the relational structure, the structure of your tables, is going to be completely different. And you should not try to design it so that the way it looks, so that it resembles the real world. There are different principles in designing of databases. So how this, and then we need to map from the relational structure to the object structure. And this mapping, I think, should not happen one-to-one. So the Hibernate encourages us to name our objects by the names of tables. So the Hibernate is actually encouraging us, or any ORM, is to create, we have 15 objects, we have 15 tables in the database. Okay, we're gonna have 15 objects in the ORM, 15 data objects or data classes. So we just do the one-to-one mapping, which is wrong. Because relational structure and the logic inside relational database is completely different from the logic in the design of classes in Java. We should not map them one by one. We should create objects which look like business objects. And then how these objects how they're gonna communicate with the tables, it's their business. How the car object will, how the garage object will find all the cars which exist in that garage, it's up to this object, it's his business. Its business, his business, her business. But it's a business of an object. It's not a one-to-one mapping. Maybe it's going to be 2 requests. Maybe it's going to be 5 SQL queries. Maybe it's going to be 0 SQL queries. Maybe it's going to be some calls to some files. So everything will be encapsulated. It's not one-to-one mapping. In Hibernate, it's in most cases one-to-one mapping. We just map in one by one, and then Java programmers tell database designers how to design databases. It happens. And then the database designers are supposed to understand Java programmers, and then they try to find try to find some compromise. It's wrong. The database design goes on its own way, and the Java design is its own approach. So they're completely 2 different worlds, and they're not supposed to be mapped one by one. The relations, the database, it's a job of a database designers, and they know how to do it right. And then the Java coders, Java programmers, they just maybe ask this database guys of what's the best way to request a list of cars. And they say, you know what, you need to do 2 joins, 2 different SQL queries, and then it's all the data you will map this way, and then you will get a list of cars. That's fine for me if I'm the Java developer. I'll make all these requests. Everything is going to be inside my one object, which is called garage. So I tried to answer your question. Maybe I didn't get it, because I'm not an expert in JDD. But thanks for asking. The next one. Create many combinations of methods to use only one transaction is not good enough. You will get many methods violating your own rule about good class have 1 or 2 methods. That's right. That's a good question. So the question is that I just said a few minutes ago. So if you want to, you have a class user, and then in this class you need a method rename, like change the name of the user, and then another method which is change the password of the user. And then you want people to be more effective, your clients, and you introduce the method number 3, which is doing rename the user and change the password. And then probably somebody else will come in and say, I want to change the image of a user, and then you will have a huge combination of methods. And then it's a good point, a good question of the object will grow. And like I'm saying, I'm always in favor of small objects which have just 1, 2, maybe up to 3 methods. So in this case, if you see that it's happening, that the object is growing, then it means that it's time to refactor and break this object down into smaller objects. So definitely you should keep your objects small, and if you see that the amount of methods is growing, it's bigger than 5, then definitely something wrong, and probably you misunderstand the business concept. Probably you misunderstand the role of this object, because if the object needs so many methods for manipulating of what's inside, maybe your object is too big. So the object has a name and the password and then an image. So maybe you introduce another one, which will be called a profile of a user, for example. So you break it down into pieces. And then if you want bigger transactions, for example, you want to be able to do some big, huge manipulation with the data, which just accepts like 5 parameters, and it does like 15 SQL queries at the same time, and then returns you something back. Then introduce another object, which is specifically designed just for one transaction and can handle just one specific request. So you keep your objects small, and if you need to grow them in size, if you see that more and more methods are being introduced, then it's time to stop and refactor. That's what I'm doing. That's my experience. So when I start design the application, I start with just a few objects. Just here, and there, just maybe 5 different objects, and then I see that the application works, I see the functionality, and then I understand, okay, maybe it's enough to introduce 2 more, and then 2 more. So never map the relational structure, like I just said, to Java world one by one and say, boom, we have like 15 different objects. It's a huge amount of code to write. No, start with 1 object and call it database, and then the next step, break it down into 3 different objects, into 3 different classes. This is now not only the database, but users, cars, and garages. And then it's not enough. The cars is not enough because there's so many manipulations with the cars, and you need cars and car. Okay, the next step, you need car, and you need like maybe some subclasses, like, you know, vehicles, and then you need like trucks, and then something else. So you grow your Java, the Java model, the collection of your classes in Java, it grows, it becomes bigger, always to keep your classes small, and at the same time interact with the database the way it needs to be done, and avoid duplication of code. I hope I answered the question. The next one. This approach does not violate the single responsibility principle, ? Because you have an object with 2 responsibilities: to be a representation of a user and to know how to save the user state to the database. Good question. So the single responsibility principle, it's basically the principle of encapsulation. It's the principle of the entire, well, not the encapsulation. Yeah, the single responsibility means that, yeah, 1 object or 1 method has to do 1 thing, and that's it. You're saying that that there are two responsibilities. First of all, my user is a representative of a user in the real world, and at the same time, it's responsible for persisting the data in some database layer, in some persistence layer, in MySQL, for example. I don't think that the first one is that the first one is actually responsibility, because every object is, the role of an object is to be a representative of a real world entity. If it's a car, then there is some real car in the world. If it's a garage, then there's a real garage in the world. So if in the real world that's going to be a user interface, and then in real application, you know, if I would write this user class, I would create user as an interface, of course, with the method rename, and then I would create a class which I would call MySQL user. So I would call it maybe my user or MySQL user, and this MySQL user would implement the interface user and implement it the way that it interacts with MySQL. So the MySQL user is a class which represents a user, which represents a user in MySQL database. So it's a single. I think it's one responsibility. So I'm being a user. I represent a user in the database. So for you as my client, I look like a user who can change the name. How I change the name, it's my business. I have the database behind me. I have the MySQL somewhere there. You don't know about that. You don't care about that. You come to me, you say rename. I do my job. I rename. This is my single responsibility for you. So all I do for you, I look like a user. There's a user banner on my forehead, and I can change my name. You come to me, I look like a user. I work like a user. It's going to be it's a database behind me. You don't care. You don't need to know about that. You just instantiate me. You give me, of course, when you instantiate me, you give me the information about where the database is. So where is in the real world they can find my database, and then you instantiate me. The user is the object is solid. You cannot. It's immutable. Ideally, it's solid, immutable. You cannot change it. It is connected to the database. That's it. Now you talk to me. You want to rename me, I can do it for you. You want to change my password, I can do it for you. So this is I think it's one responsibility. That's one thing I'm doing, being a user. We have a few questions more and 5 minutes left. what is the best alternative to ORM? If you use SQL speaking objects with specific dialects, for example, MySQL specific functions, it's less maintainable. Will that can it be solved by specific adapters? That's a good question. Of course, like I just said, for example, I create MySQL user, and of course this MySQL user, if inside this MySQL, I'm going to use a specific MySQL dialect, which will go to, well, we'll use the SQL requests with specific syntax of MySQL, then yes, this user will be unmaintained. Well, it's just one specific implementation, which is difficult to maintain. If I want to migrate to Postgres, I need to rewrite the whole class. I need to create new class, which will be called Postgres user. And then I want to create Oracle user. So we will have 3 classes. And probably there's be a lot of code duplication inside. Because these 3 classes, they will do almost the same stuff, except just small minor syntax changes in SQL requests. That's why the libraries like Juke, for example, or JDBC are created. So JDBC is the first layer. So the JDBC helps us to avoid specific details of how to connect to the database. So you don't need to know how to connect to Oracle. You just use a different JDBC driver. You just replace the driver, you connect to Oracle. That's done. So we can create a JDBC user, for example, a user which will know how to communicate with JDBC. But still there is a different dialects. In order to solve that, we can use, for example, this Juke library, which has a specific implementation which knows about different syntax for different databases. And you, instead of using SQL text as a text, instead of specifying request in a text, you create an object of this library, and you call methods on this object, and then the library will create a real request for you. So that's a solution. There are probably more libraries like that, but I'm aware of this one, and it's quite popular. You can create your own library. You can create something which will help you to design this to replace, well, to unify the way you create requests. But of course, it's better to use a library, because the developers of it knows how to translate your select star from users where user ID is 1. Select this, translate this request to different dialects of different databases. So like on the diagram, the first layer is, for example, this Juke library, the second layer is JDBC, and then the real MySQL. That's how you make it maintainable and, maintainable. The last question, well, this question I already answered. It says, does the user have to be an interface? Yes, the answer is, of course, the user has to be an interface. That's how I do it usually. So I believe that every object has to have an interface which it implements. So in this case, the same. So first of all, you create a collection of interfaces which look like a business domain, like business objects, and then you implement them with, for example, car, and then Postgres car, and then garage, and then Postgres garage. So of course it has to be an interface. And the last question is this: do you see the ORM anti-pattern also relating to the pattern that you would use for RESTful interface using in the object-oriented application, and other the same pitfalls? It is close. Using it in an object. Yeah, I think, yeah, the RESTful, it's not exactly about the subject we're discussing now, but yeah, the design of RESTful applications are also in Java also done wrong, because the JAX-RS is the standard which is used in Java, and which is based on, again, static methods and completely anti-object-oriented approach. It's similar, yeah. It's a similar mistake being made in Java world. So they made it with ORM 10 years ago. I don't know how long time ago. And with the RESTful API, the JAX-RS, it's exactly, well, it's very similar problem. So just people don't understand what object-oriented is about, what OOP is about, and they just use Java as a tool to just implement what needs to be implemented. And then thousands of programmers across the world just go the wrong way. And that's what I'm trying to, I'm finishing. That's what I'm trying to solve with the book I'm going to publish in a month. So in about 4 or 5 weeks, it's going to be, you can check it on my blog. I'm publishing a book which is called Elegant Objects. It's a book about object-oriented programming and how it can be done the right way. Well, it can be done the way I think is the right way. Follow that, just stay tuned. I'm going to publish when the book is ready. I'm going to publish the news. And in the book, I'm discussing this subject as well, about ORM and about this approach to design of objects and how to do it right and how to follow the principles of encapsulation and the single responsibility and all that stuff. So to summarize, the ORM and the Hibernate is an anti-pattern, like I just explained. Try to stay away from that and use SQL-speaking objects, the objects that encapsulate the interaction with the database and they know what to do. Now, the last question is when I'm going to be in the Netherlands. I'm not sure now, but hopefully before the end of this year, I'll definitely be there. Okay, stay tuned. Thanks for listening. Happy coding. Bye-bye.